Hello everyone, this is kind of different from my normal YouTube video, but in this video I wanted to give everybody something in case you're working in Unity. Let's say you have a car game and you want to have actual realistic gauges inside the car, not just on screen but inside the car as well. Well, there's plenty of tutorials online that shows you how to put car gauges as a UI, but not in the game like I've done right here with this particular car that I bought on the asset store. So if you have a car that you would like to actually get the interior gauges to work, well, I got the script for you down in the description. What's cool about it is that not only does the speed gauge work, but so does the RPM gauge work as well. Now the code that I wrote for this is partially due to a tutorial from CodeMonkey, as well as the basis of the code is mostly due to I mostly base it on AD Vehicle Script. So you can rewrite certain parts of the code to work with your work in your case as well. So we got the fuel gauge working. You can't really see because the hand is in the way, but the RPM gauge is also working as well, along with the speed gauge. And if I put it in reverse real quick, the gauge doesn't go back in the other direction. So yeah, let's go ahead and take a quick look at the code and see what you can change for yourself. You could copy and paste it from the description down below, and let's get started. All right, let's go ahead and get started with the actual gauges of the code first. As you can see, I'm using AD Vehicle Script for the basis of my code, but like I said, you should be able to rewrite it for your own use case as well. Luckily, AD Vehicle Script comes with the RPM simulated RPM range, and that's what I use to capture and translate the RPM reading inside the 3D world. But let's go ahead and get started here. Obviously, we got a boolean for whether or not I set the script from kilometers per hour to miles per hour. I have a conversion for that. Then down here, we have the min and max angle for the gauges to rotate on, based on whatever axis you want to put it on. In this case, these gauges rotate on the x-axis, so that's the rotation I stuck with. Now, when we look at this, it goes in the opposite direction. So if I turn it clockwise, for some reason it's negative, so that number is going to be negative. That's the maximum. Now, this is one of the most important parts right here, the max speed. Max speed is not the vehicle's max speed, but the max speed that's displayed on the gauge. That's what you want to set in there. So wherever gauge you're using in your vehicle, wherever the top max speed is on that gauge inside the vehicle, that's what you want to set. And of course, we have the speed variable. You don't need to change anything with that. There's your needle transform for the actual needle. And right here, RPM, same as the speed angle up here, RPM angle rotates the same way. It's actually practically 1-for-1, but yeah, that's where it's set at maximum RPM. Now, I got this wrong. This is the maximum RPM you want to set on the gauge, not the maximum RPM that your car can do, but the maximum RPM on the gauge itself. Set that to wherever the max reading is. The same with the max speed. Max reading on the RPM, set that. The needle, obviously, Now here, like I said, I'm using Eddy Vehicle Script, the vehicle audio controller and the vehicle controller. You can change those to wherever scripts you're actually using to control your vehicles with, to get your RPM sound and your vehicle from. Switch it to that, and it should work. As long as you input the right correlating variables, I should say. Then down here is the fuel gauge. Now the fuel gauge is a little bit tricky because I wanted to rotate in a completely different direction from the other gauges to make it more natural looking. So you may have to play around with the variables on your vehicle if you decide to use it. Of course, we're setting the controllers in the start menu, update menu. Obviously, we're updating the fuel gauge rotation. That's going to come later, as well as the other gauges are being updated and the gauge operation running. These are the angles being updated for the speed gauges. Take note here, we're using a local Euler angle rather than the Euler angle, because the Euler angle is world space. So if you were to use regular Euler angle, I can't really say it. If you were to use that function instead of the local function, it will maintain the world angle rather than your actual angle inside the car. So it's very important to use those. Now let's get on to the fun part. This is what I use to control the speed of the gauge going forward, and this is only forward. All right, I got this from CodeMonkey. This is how I started this on his tutorial on setting up a speed gauge, although he did his in a 2D space. This is to handle the vehicle going forward. Now, he didn't cover how to handle the vehicle going backwards. Well, luckily, it wasn't too hard to figure that out, because all I did in this float function was switch this plus sign to a negative, solved all the problems. So now, even if you're going in reverse, because up here is determining whether or not which function to use depending on which way you're going, whether you're going forward or you're going in reverse, it will decide which one of these functions to use. So then the RPM gauge is constant. Luckily for me, the EVP, Eddy Vehicle Physics, he already calculates going forward and reverse on the RPM gauge, so I don't need to change any of that, because it'll work both in forward and reverse on there. And of course, we're getting the fuel angle. Like I said, it was a bit tricky for me to work that. You could rewrite this as you need to, but it's a bit tricky for me to explain how to, because I had to actually take the fuel level, which I needed to flip in reverse, so do it as a negative rather than a positive, because I have the fuel level normalized. That way, it will actually trickle down to the right as it goes down rather than counting up. It'll count down. So it'll actually rotate to the right instead of to the left, which is my desired effect, although it did take me a few tries to find the right angles to use. I'll show you those angles in the inspector. Now, of course, the speed converter, it will actually return this speed, which is my main speed, which is being calculated in speed output and reverse speed output based on here, miles per hour, kilometers per hour, to show up on your gauges. So that is speed in a nutshell. That's the speed gauges. That's the fuel level gauges. Now the fuel system, which is another script I'm including in this in the description here. The fuel system itself is a little bit easier to understand. So this is the fuel system. We have our max fuel usage, our max fuel usage, which I have set here, our minimum fuel usage, because it's on a scale between 0 and 100. So this is how much it's going to be using over time. the minimum fuel usage is mostly minimum maximum fuel usage that the vehicle is going to use is largely based upon the player's input, how much fuel they're using. So if they're using like a certain amount of throttle, it's going to determine how much fuel is going to be used. Then we have the current fuel rate, or the fuel usage rate. I only put this there to display in the inspector so you can actually see, depending on how much throttle you're using, it's how much fuel you're using. And if you're using like Xbox controller where you can actually control, or a foot pedal where you can actually control how much throttle you're using, you'll actually be able to see those numbers in the inspector as well. And those are the numbers that's going to be reducing the fuel level over time. So obviously we have our gauges, so we can actually send that information to our gauge so it can update the visuals inside the car on where the fuel level is at. And of course we have our vehicle controller, which you could rewrite for your own vehicle. We're grabbing the controllers that we need, setting our max fuel level, our fuel usage rate. Obviously this is to show where the fuel usage rate is in the inspector. Here we have the current fuel level, which is being reduced by the fuel rate over time.delta time. And if it goes below that, it's going to read 0. So this is where the fuel is being normalized to actually be sent over to the gauges. So it's being normalized on a scale from 0 to 1, being normalized so it could be able to translate into the fuel level. That way, that could be displayed inside the car where your fuel level is at. So this is our fuel rate usage, which is obviously being subtracted over time. So what I'm doing here is I'm taking the minimum, the idle usage, which the car is on, is going to use fuel, so the idle number, and the top fuel number, the top throttle, full throttle, how much fuel is going in, or in this case, how much of a number I'm taking away, and I'm plugging that into the adjusted rate. So the differences between those two is being placed in here. What the car is going to do is going to return the idle fuel usage rate. So it's going to start off at the bottom, right? It's subtracting the number between these two. So it can only go to the maximum of full throttle. So if the player's not pressing full throttle, it's going to return the idle usage, which is in this case 0.05. If the player goes full throttle, they'll multiply the adjusted use rate by the throttle input and then add that onto the idle input. So it will come up to the maximum number, which is 0.09 that I have it currently set to, which you can also change in the inspector. But it will come up to that rate. Without this, player doesn't press the throttle at all, it'll only take away from that. If you press it full down, he'll pretty much be using the full throttle number. However, if he's doing half or quarter or 3/4 throttle, then he's going to be using a number somewhere between these two. It'll never go below the idle fuel usage, but it'll never go above the full throttle usage. It'll always be somewhere in between. And that is it in a nutshell. So let's hop back over into Unity, take another look, and see it in the inspector as I use these numbers. Alright, so we're back in Unity. Let me go ahead and get in the car, and we'll go ahead and start with the tachometer. See the usage of that. As you can see, tachometer speed is matching what the RPM is doing. And because Eddie Vehicle Grip handles the audio RPM, it already keeps it at a positive number. We don't have to adjust that at all. As you can see, it's still keeping up roughly accurate to where the RPMs are. Now let's take a look at the speed. Now if we look at the speed, the speed is fairly accurate. Try to keep it around 20 miles an hour. As you can see there, speed is fairly accurate, off by a few miles per hour, but still fairly accurate. And if I go in reverse, the tachometer doesn't spin in the other direction. It just keeps going in the correct direction, showing you where the speed is. Well, I hope you guys find a use for the code. If you have 80 vehicles physics, you can go ahead and just plug and play. It should work right out the box. If you have another car controller that you use, just swap out the car controller variables and it should work just fine for you. Hope they just let me know whether or not you guys want any additional code like the one I'm following right now, which is a car that's following waypoints but using A-Star pathfinding to navigate to each point. If you guys want that code as well, just let me know down in the description and I'll work on getting that one commented and posted up on itch.io as well. I might actually put together a whole project for that one. Hope you guys have a wonderful day. See you next time.